Now, I'm going to do a video to see if I can determine which instrument is more accurate, and how can we tell whether or not one instrument gives a more accurate value than another, and is there a simple way to tell? So let's do this. And intuitively, I think you're going to be able to figure this out. Okay? So let's do this. We're going to pour some material into, come on in guys, you can go over here. I'm filming, come on in, you can go over here, and I'm almost finished, okay?
Alright.
Come on in. You can come in, everybody can come in.
I'm just saying hi.
Okay, hi, how are you doing? Just saying hi?
Hi.
Okay, I'm making a video, but that's good. Hi, these are some students from last year who I know very well. How are you? I'm awesome, exactly, we're trying to stay positive. Excellent, you're very awesome too. Everyone's awesome. It's always good to say positive things about people. But I've got to be somewhere at 3:15, so I've got to finish this.
And we have to go to the bus.
You have to go to the bus. Well, don't be late. You don't want to walk home in this sun. And remember, you're awesome. Excellent. Okay. Some students from last year. Very sweet. Okay, now. So, what is this measurement going to be? You see that it's a little bit above the line, but it may be a little bit too close to call. So we'll say that it's too close to call. I'm just waving my hands and saying that. In other words, I'm just saying that it's too close to call. Let's just agree on that. So, let's write the precision for this instrument first. We see that this is tens place. 2 less than tens is going to be ones, tenths. So this is going to be plus or minus 0.1. And then the precision of that instrument is going to be, this is ones, 45, 46, that's ones, tenths, hundredths, so it'll be plus or minus 0.01. Okay, now, so let's do the measurement for A. All right, let's do the measurement for A. I got a good solid 5 minutes, short video, we can do this. Because you know how to make measurements. You should know by now how to do uncertainty, which is the same as precision, how to make a reading, and now you also know what a significant figure is. And that's important. Okay. Because I want to teach you if the number of significant figures is important. That's the next step. So everything is very step by step. Okay? So, right. So this is going to be 45. And we're going to say it's right on the line. We have to make the measurement to tenths place. So it's 45.0. We're saying that's exactly on the line. So this measurement is going to be 45.0. That's the measurement. Now, we're going to take the same material, the same exact material. You have to do this with the same material. And we're going to get every bit of material out. We're going to pour it from here into here. And I'm saying that it's going to end up right there. I'm going to say it's going to end right there. Okay? Now, so, what's the reading going to be? What's the reading going to be? Now, when I do this, it's not something that's terribly unusual. It looks like it's unusual, but it's really not. Okay? So, remember, this is the same material. Okay. So we're saying that's going to be there, and we're going to say that that's B. And we're going to say that's going to be 45.5, exactly on the line. And we're going to say that it is going to be 45.50. Okay? 45.50. So it's really not on the line, is it? Plus, this could be poorly constructed. So if you have error as a result of the construction of a piece of laboratory equipment, we assume there's going to be human error. We don't talk about human error. You write on your lab reports, well, there was human error, I spilled some water. Okay, you spilled some water, but how did that affect your results? And that's okay. But you just don't say, wave your hands and say there's human error. What was the error, human error, and how did it affect your calculations? However, when there's error as a result of the construction of a piece of laboratory equipment, that's what we call systematic error. That is error that has no control, that can't be controlled by the experimenter. That's only controlled by the instrument itself, by the system you're using. So, we could say that that's systematic error. But that's not really my point. I wanted to make that point, but that's not my point. But my point is this, that this has 3 significant figures in it. Same material. This has 4 significant figures in it. Same material. I'm saying to you this, that the instrument that produces the most number of significant figures given a material, could be the same here, same, right, fair enough, is the more accurate instrument. Now that's important. That's all you need to know. That's all you need to know. Remember, this is a stepwise step. We're doing this step by step. So that's the lesson. The lesson is simple. I have instrument A, instrument B. Precision, precision. Measurement, measurement. 45.0, same material, 45.50. 3 significant figures, 4 significant figures. 3, 4. This is more accurate because it generates more significant figures. So significant figures are important because they can denote accuracy. They can denote accuracy. Are we there? They can denote accuracy. So, the next video is going to be on precision. Can precision, what is precision, and what can I use to mechanically describe precision? What do I mean by mechanically describe? In other words, I can mechanically describe accuracy. I can say that accuracy, listen carefully, accuracy is a function of the number of significant figures. Accuracy is a direct function of the number of significant figures. Let's go one step further. Accuracy is a linear, direct function of the number of significant figures. The greater the number of significant figures, the greater the accuracy. The lower the number of significant figures, the lower the accuracy. So it is a direct linear function. High number of significant figures, high amount of accuracy. Clear? That's the mechanical way of determining accuracy of an instrument. Let's see on the next video if there's a mechanical way of determining the precision. What instrument is more precise? And let's look at precision in a way other than the uncertainty of an instrument. Have a good day.